Hello guys, I am Satish Samudrana. Welcome to Gateway to Learn Educational Concepts. In the last video, I told periodic table series. Let's discuss about periodic table. Periodic table. Dmitry Mendeleev, mid 1800s, proposed a table for 70 elements based on increasing mass and similar properties. Next one, Henry Moseley in 1913 determined the atomic number of elements and arranged the table in order of increasing atomic number. Next one, periodic law. Regular variations are patterns of properties with increasing atomic number or atomic weight. Both chemical and physical properties vary in periodic way or repeating pattern. Group. Vertical column of elements or family. Period. Horizontal row of elements and family. Next one, groupings to know on the periodic table. Representative elements. Group A elements, columns 1A to 8A. They are included in three types. One, metals. Second one, non-metals. Third one, metalloids. Let's discuss about metals. Characteristics: high electrical conductivity, high luster. On the left side of the periodic table, except hydrogen. Let's discuss about non-metals. Characteristics of non-metals. In the upper right corner of the periodic table, non-lustrous, poor conductor of electricities. Some O and Cl are gases at room temperature, etc. Let's discuss about metalloids. Characteristics of metalloids. On the stair-step line that divides the metals from the non-metals. Exhibit properties that are the intermediate between those of metals and non-metals. Important metalloids: silicon and germanium. Let's discuss about periodic groups. Periodic groups can be divided in 6 types. 1, alkali metals. Second one, alkali earth metals. Third one, transition metals. Fourth one, inert transition metals. Fifth one, halogens. Sixth one, noble gases. Let's discuss about alkali metals. Alkali metals are group 1 on the periodic table. Alkali metals are very reactive. Alkali metals are soft solids. Alkali metals are readily combine with halogens. Alkali metals are tendency to lose one electron. Examples of alkali metals: sodium, potassium, cesium. Let's discuss about alkaline earth metals. Alkaline earth metals are group 2 on periodic table. Alkali earth metals are abundant metals in the earth. Alkali metals are not as reactive as alkali metals. Examples of alkaline earth metals: magnesium, strontium. Let's discuss about transition metals. Transition metals are group 3 to 12 on periodic table. Important for living organisms like as minerals. Examples of transition metals: iron, zinc, manganese. Let's discuss about inert transition metals. Inner transition metals can be divided two types. One, lanthanides. Second one, actinides. Let's discuss about lanthanides. Lanthanides are part of the inner transition metals, soft silvery metals. Lanthanides elements are 57 to 70. Examples of lanthanides: cerium, europium, ytterbium. Let's discuss about actinides. Actinides are radioactive elements. Actinides are part of the inner transition metals. Actinides elements are 89 to 102. Examples of actinides: uranium, plutonium, berkelium. Let's discuss about non-metals. Non-metals can be divided in two types. One, halogens. Second one, noble gases. Let's discuss about halogens. Halogens are group 17 on periodic table. Halogens are a salt former. Combines with group 1 and group 2 to form salts or ionic bonds. Examples of halogens: fluorine, bromine, iodine. Let's discuss about noble gases. Noble gases are group 18 on periodic table, relatively inert or non-reactive. Noble gases at a room temperature. Examples: helium, argon, radon. Let's discuss about chemical properties and families. Chemical properties of elements are based on their valence electrons. Families are groups of the elements that have similar valence electrons. Valence electrons equal to outermost electrons in an atom. Valence electrons. In general, the number of valence electrons of a representative element is equal to the group number. Once again I tell, valence electrons. In general, the number of valence electrons of a representative element is equal to the group number. Next, let's discuss about periodic properties. Periodic properties can be considered: 1, atomic radius. Second one, ionization energy. Third one, ionic size or radius. Fourth one, electronegativity. Let's discuss about atomic radius. Group trend in atomic radius increases as you move down a group because electrons are added to higher energy levels. Atomic radius in periodic trend decreases as you move left to right across a period because as the number of protons in the nucleus increases, the positive charge increases, and as a result the pull on the electrons increases. Once again I tell, periodic trend in atomic radius decreases as you move left to right across a period because as the number of protons in the nucleus increases, the positive charge increases, and as a result the pull on the electrons increases. Next, let's discuss about ions. Ion, an atom or group or atoms that has a positive or negative charge. An atom is electrically neutral because it has equal number of protons and equal number of electrons. Next, positive and negative ions form when electrons are transferred between atoms. Atoms of metals tend to form positive ions by losing one or more electrons from their valence or outermost shell. An ion with a positive charge is called a cation. Once again I repeat, an ion with a positive charge is called a cation. Example, sodium, Na form to Na plus. Atom of non-metals tend to form negative ions by gaining one or more electrons, thus filling their outermost energy level. An ion with a negative charge is called anion. Once again I repeat, an ion with a negative charge is called an anion. Examples, chlorine, Cl form to Cl minus. Next, let's discuss about ionic radius. Anions, negative ions have full valence shells. They are larger than their neutral atom. Once again I repeat, anions, negative ions have full valence shells. They are larger than their neutral atom. Next, cations, positive ions have empty valence shells. They are smaller than their neutral atom. Once again I repeat, cations, positive ions have empty valence shells. They are smaller than their neutral atom, but the size of one ion compared to the next is the same pattern of atomic radius. Once again I repeat, but the size of one ion compared to the next is the same pattern as atomic radius. Next, discuss about ionization energy. Definition of ionization energy: energy required to remove outer electrons results in the formation of a positive ion. Once again I repeat, definition of ionization energy: energy required to remove outer electrons result in the formation of a positive ion. Ionization energy in group trend decreases as you move down a group because electrons are in higher energy levels. As you move down a group, they are further away from the positive pull of the nucleus and therefore easier to remove. Once again I repeat, group trend in ionization energy decreases as you move down a group because electrons are in higher energy levels. As you move down a group, they are further away from the positive pull of the nucleus and therefore easier to remove. Ionization energy in periodic trend increases as you move left to right across a period because the increasing charge in the nucleus as you move across a period exert greater pull on the electrons it requires more energy to remove an electron. Once again I repeat, periodic trend in ionization energy increases as you move left to right across a period because the increasing charge in the nucleus as you move across a period exert greater than pull on the electrons. It requires more energy to remove an electron. Next, let's discuss about electronegativity. Definitions of electronegativity: the tendency of an atom to attract electrons of another atom. Once again I repeat, definitions of electronegativity: the tendency of an atom to attract electrons of another atom. Electronegativity in group trend decreases as you move down a group because higher energy levels means the electrons are further away from the nucleus. Greater distance equal to decreased attraction. Electronegativity in periodic trend increases as you move across a period. Noble gases excluded because nuclear charge is increasing, atomic radius decreasing. Once again I repeat, electronegativity in periodic trend increases as you move across a period. Noble gases excluded because nuclear charge is increasing and atomic radius is decreasing. Let's discuss about electronegativity. Most electronegativity element is fluorine 4 point. Least electronegativity element cesium 0.7. That's it. Main key points in periodic table. Like, share and subscribe for more videos. Thank you for watching. As soon as I will upload each and every element details in periodic table.